just dropped off your license.
Rightio, there are plenty of ways that we could do this. You've seen with laws of exponents, we could do whatever order we really like, but you'll get into a more efficient method. So there are probably two laws that are applied here. One of those laws is the distribution of an exponent, right? Remember that? If we have a over b to the power of m, how can I write that in another way? Okay. So it gets distributed between both. Okay. So my first step here would be to do yes. Yeah. All right. Now, the next stage would be to use the stuff that we were talking about last time, which is that to power of a half is the same as the square root. So we've got a square root of 1 divided by the square root of 4, which equals 1 divided by 2.
Where?
Wait,
Whoa.
whoa.
Oh.
What's the square root of 1? What's the square root of 4?
Oh,
2.
right.
What if it wasn't a 4 and if it was a 3?
You just leave it.
You just leave it as a surd, yeah, leave it as 1 over root 3. But let's have a look at that actually. Not an example maybe in the book, but I would quite like to go through it. So what if we had a similar example, but it was 1 over 3 to the power of a half? What could we do?
You separated one.
Yeah, thank you. Yeah, I was waiting for that. 1 to the power of a half divided by 3 to the power of a half, which is then square root of 1 divided by the square root of 3, which is equal to 1 divided by the square root of 3. Now, is that a good final answer?
No.
Yes.
Yes.
But like now.
No.
Because apparently
No.
I think it is.
Thank you, Maya. Yeah. That's the difference between someone that's applying one process and someone that's applying everything they know. All right? Because when we've got that, that is an equivalent statement, but what should we do? We should rationalize the denominator. Now, do you remember how to use your surds to rationalize the
You
denominator?
multiply. So then it. Oh, I get it.
So it'd be 1 times root 3 divided by root 3 times root 3. Do you remember why I multiplied by root 3?
To get rid of the root.
Because root 3 times root 3 is equal to 3, and 1 times root 3 is root 3. So you might say, well, that just looks, that's not as nice looking, but actually it's we've rationalised the denominator. So we should get into the habit of, I mean, that's kind of one part, but then we should get into the habit of rationalising. Okie doke. That wasn't one from the book. I just kind of thought I brought that one because that's yeah. Shall I do one more with the negative then? Right.
Yes.
So let's look at B. B is 1/16 to the power of negative 1/4. Do you remember those numbers I said that you need to get into the habit of remembering? What were they again? 2, 4, 8, 16, 32, 64, 128, so on, yeah? So we noticed 16, so what do we think it's going to end up being? It's either going to be a 4 or a 2, isn't it? So the fourth root, we're just expecting it. It's not going to be anything hard, yeah? So what do we do then? Well, we go with, it's 1 to the power of negative a quarter if we want to do that, divided by 16 to the power of negative a quarter. Happy with that? Now, do you mind, not that you've got any choice in the matter whatsoever, but do you mind if I kind of go sort of into the deeper explanation of what's happening, rather than just give you the shortcut? So what I'm going to do to explain this is I didn't have to split it in that way first. All right? In fact, I'm going to choose not to. And I'm going to go back to this stage and do it in a different way. And instead of distributing the power first, I'm going to deal with the negative first. So I'm going to write it as 1/16 to the power of negative 1 to the power of a quarter.
Is that better? Because or
A what? Negative? Yeah. Do you remember when you've got them either side of a bracket, you multiply? So what negative a quarter is?
But like,
Why would I do that? Well, because do you remember what happens when you do something to the power of negative 1? I've been through the explanation. We're not making it negative. It doesn't make it negative. It's 1 over 1/16. So let's just have a look over here. I'm going to change my colour just so you know. What is 1 divided by, or 1 over 1/16? Well, that's messy. So let's rewrite. What does 1 divided by sometimes look like? 1 divided by 1/16. Yeah? Got that?
it's just
So it's 1 multiplied by
16. So it's 16 because whenever 16 goes into 1/16.
Yeah, exactly. One divided by 16ths is, if you think about what division is, how many 16ths go into 1? 16. Yeah? So instead of just thinking, negative flips it upside down, you've got a bit of a deeper understanding now. But what we can say, and maybe you'll appreciate why I've said this bit here, all right, just the inside bit I'm going to deal with first, and I'm going to say 1/16 to the power of negative 1 is actually just 16. So I'm going to rewrite that as 16 and then put these brackets back and this quarter back. Well, now I don't need the brackets, do I? But you can then tell me what is 16 to the power of a quarter. It's the same thing as doing the 4th root of 16, and because you've memorized your numbers, what 2, yeah? So 2 times 2 times 2 times 2 makes my 16. So the answer is 2. All right. Now I would have got the same way going this way, but I think up here I would have had to have just said to you, we do the, would it work the same thing if I did the 1 to the power of a quarter first? So it's 4th root of 1, but still to the negative 1. We would have still had to have done that. Divided by the 4th root of 16, but still to the negative 1. Happy with that? 4th root of 1 is 1, so I've got now 1 to the negative 1, and the 4th root of 16 is 2, so 2 to the negative 1. And what would we have then had to do? Well, this may be where it's... So then we kind of get into the habit. It just looks a bit messier than the way I did it. And I would have probably ended up going, do you not remember when it's negative? You just put the one on the bottom on the top and the one on the top on the bottom, yeah? So we would have just gone, well, that's the same as 2 to the power of 1 over 1, which is... But there'd have been less explanation, less understanding, all right? And I get the same answer, don't I? 2 and 2, right? 2 over 1. But you can deal with the the negative bit separately, and then the quarter bit separately. Don't, the one thing, I think we should put this, and you should put this in your notes, right? Probably really important. Negative exponents do not make the number negative. But one or more of you will do that in a criterion A test. I'm pretty sure of it. So it's up to you now to prove me wrong. But I do this every test, and one of you will do it. Even though you've never been taught it, one of you will have made that statement in your head. And I find it very difficult to get rid of it. But negative exponents do not make the numbers negative. Right? Does that help you then work out through the rest of them? Cool, I'll leave you to it.